So now it's time to learn balancing redox reactions. So in balancing redox reactions, you can use two methods. The first one is half equation method, and the second one is change in oxidation number method. So let's learn for the first one. So I took this example for balancing redox reaction. So the first step is you need to break down this equation becomes two half equation. So the first one is the change in bromine. So Br minus becomes Br2, and the second half equation is MnO4 minus becomes Mn2 plus. So I just want to clarify that this one is the charge, okay, the total charge of the polyatomic ion. Okay, next, so let's balance the first half equation. Since the number of bromine in Br minus on the left and at the right is different, so you just need to multiply by 2 at the left hand side, because at the right hand side there are 2 bromine atoms. Okay, and then the next step is you have to calculate, you have to balance the number of electrons, the total charge at the left and at the right, by adding electrons. So let's have a look here. We have the total charge at the left hand side is -2. 2 multiplied by the charge, so the total charge is -2, while at the right hand side the total charge is 0. So we need to add 2 electrons here. Okay, so now the first half equation is balanced. The next one is we need to balance the second half equation. So since the number of the manganese at the left and right are the same, so we don't need to balance. Next one, let's move on to balancing the number of oxygen. Since at the left it has 4 oxygen, so we need to balance the number of oxygen, we need to add water molecules. How many water molecules do we need to add? It depends on the number of oxygen. Since we have 4 oxygen at the left, so we have to add 4 water molecules at the right. So now at the right it has 4 oxygen and 8 hydrogens. So how to balance the number of hydrogens at the left? So we need to add hydrogen plus ion or H plus ions. So how many hydrogen at the right? 4 multiplied by 2, so we need to add 8 H plus ions to balance. Okay, so now the number of each atom has have been balanced. Let's go to the total charge. So now at the left hand side the total charge is +7, -1. +8 and -1. So the total charge is +7, and at the right hand side only +2. So the difference is -5. So the difference is 5. So the difference, we can balance this by adding the number of electrons. So here we just need to add 5 electrons at the left hand side and 4 H2O. Okay, so now our half equations are already balanced. Okay, so now it's time for putting those two half balance equation into one frame.
So 2 Br minus becomes Br2 plus 2 electrons and 5 electrons plus 8 H plus, and Mn4 minus becomes Mn2 plus 4.
Okay, so what does it mean by the electrons at the right and at the left here? So it means that the first half equation, the electron is losing electrons, 2 electrons, while at the second half equation it means that this manganese is gaining 5 electrons. Okay, so now so how to balance the number of transferred electron in redox reaction? We just need to multiply by 5 for the first equation and multiply by 2 for the second equation. So the overall reaction will be, reactants at the left hand side will be still at the left of the arrow, while the reactants at the right hand side will still be at the right.
So 10 Br minus plus 10 electrons plus 16 H plus 2 MnO4 minus. Next 5 Br2 plus 10 electrons plus 2 Mn plus 4 H2O. 8 H2O. Okay.
So now we have overall reaction. So for the species that presents at the left and right, we can cancel them out. So we only have electrons. So the remaining ions here are the balanced redox reaction. So that is the way you solve this equation using half equation, the redox reaction using change in oxidation number method. So the first step you need to do is you need to balance the number of atoms in this equation. In the meantime, no need to balance the number of oxygen and hydrogen. We just need to balance the number of atoms that being reduced or oxidized. Here we have at the right we have 2 bromine, so we need to add in coefficient 2 in front of Br. So now the number of bromine at the left and right are the same. And next we have to identify the oxidation number of each substance that being oxidized or reduced. Here, since we already add 2 here, so just for this method, we need to multiply by 2 the charge. So the charge will be negative 2. The charge of bromine here, the total charge is negative 2, and the total charge of the oxidation number of manganese is positive 7, and Br here is 0, and 2 plus ions here is positive 2. Okay, so change in oxidation number for bromine will be from negative 2 to positive to 0. So the change of oxidation number of bromine is 2, and the change for manganese is positive 7 to positive 2, so the change is 5. So to balance this change 2 and 5, so to balance since the redox is about electron transfer, so it means that the number of electrons lose or gain must be the same. So we have to multiply by 5 and multiply by 2 here, so that it will be balanced, become 7 electrons will be transferred. So now let's focus on this one and this number. Okay, so it means that all the substance in bromine which related to bromine here must be multiplied by 5. So there will be 10 Br minus
plus MnO4 minus becomes 5 Br minus 5 Br2 plus Mn2 plus.
Okay, and how about manganese? Since here is multiplied by 2, so everything in manganese must be multiplied by 2. So here we have to multiply by 2. So we need to balance the number of oxygen at the left and at the right. Since here there are 8 oxygen, so we need to put 8 H2O, the same way as you balance the number of oxygen and hydrogen using the first half equation method. So if you want to add oxygen, you just need to add water molecules. So at the right hand side, so now we have 16 hydrogen, so we need to add 16 H plus at the left. Okay, so now everything is balanced here, but for checking is this equation correct or not, we have to confirm by calculating the total charge at the left, substance at the left, and the total charge at all the substance at the right. Okay, so now we have 16 plus here, and minus 10 here, and negative 2 here. Okay, for this substance. Okay, and now at the right we have only positive 4. Is it correct? This total is equals to positive 4. Yes, it's correct. So now let's work on the last questions. You can choose using half equation method or change in oxidation method. Every method will give us the same result at the end. Okay, see? Okay, enjoy learning.